All right, so for this question, we read that the graph of y equals f of x is shown below. You can see it there. Now the question is the number of invariant points that occur when, and then we're going to give you several transformations here and just ask you how many invariant points you get for each one. So for this first one here, the negative is on the outside here, which implies that this is a vertical reflection, okay, this way, over the x-axis. So anything that's on the x-axis is going to stay invariant. So that's going to mean that x-intercept right there and that x-intercept right there will stay invariant. That means we've got 2 invariant points. The next one, the negative is on the inside. That means this is affecting the graph horizontally. So this is going to be reflection over the y-axis, in which case all the y-intercepts will be invariant. And in this case, there's only the one, which makes sense because we're talking typically about functions here. So it makes sense that there would only be one y-intercept. If we've got x equals f of y, that is a reflection over the line y equals x. Okay, so that's coming up like this. There is, again, only one point that's on that line. And so there's only one invariant point that's going to occur here. And then finally, we've got the radical transformation. We're taking the square root of the function. Now, first of all, anything that's below the x-axis, we're not going to take into account because that's going to lead to imaginary values, complex values here. So we're not interested in that. But we know that the square root of 0 is 0. So anytime that the y-coordinate or the value of the function is 0, that will be invariant. And so that's going to correspond to the x-intercepts. But we'll also have invariant values when y is equal to 1 because the square root of 1 is 1. So anything along this horizontal line here will also be invariant. So that means we've got 5 different invariant points if we apply the square root of the function.